Welcome to qnawire.
Problem 123 asks us to find the centroid or center of gravity of a semiellipsoid of revolution that's split into two parts, two equal halves, not equal in volume but in length or height. So I can split this in half where we have equal halves. I'll call the total height of this semiellipsoid h, so h over 2 for both halves. We're going to integrate to find the centroid or center of gravity of these parts. And we're going to integrate over a differential element of a disk that looks something like that. To find the centroid, we use equation where the centroid times the volume of the component is equal to the integral of the differential element dv. And I'll label this element as, this component as component 1, and this will be component 2. So let's start off and find the centroid of component 1. So first let's find the volume, which is going to be equal to the integral of the differential volume for over each disk differential element. And we know that each small disk that makes up the part is equal to the area of a circle times the small change in x for that disk over the entire component. However, we don't know the radius, we just know the height given in this equation. So we must substitute by using the equation of an ellipse. So equation of ellipse, we have x squared over the height squared plus y squared over the width squared, which I'll call a. And looking at our diagram here, this would be A. Or excuse me, the A would actually be the radius. So in this way we have that the radius squared is going to be equal to a squared over h squared times h squared minus x squared, since y is equal to, y is equal to the radius. If we plug in the radius, because the y-axis is along the radius is along the y-axis rather. Now we can plug this into dv, and we'll be left without that radius value, which we don't know. And now we can find the volume of component 1. We'll be integrating from 0 to the height of the semiellipsoid over 2 for the first component. And we can plug in dV. In simplifying, we get that the volume is equal to 11 over 24 times pi times a squared times the height. And that a squared will eventually cancel out when we now solve for the right side of the equation, which is the integral of the differential element dV is equal to the integral from 0 to h over 2. And our differential element will keep on changing and will go along x, so we can just plug in x for that. And we also know the dV already. So simplifying, you get that it's equal to pi a squared over h squared, which are pulled out because they are known. They are not variables. We get the right side of this equation is equal to 7 over 64 pi a squared h squared. Now we know everything we need to plug into our equation to find the centroid of the first component. So the centroid of the first component times the volume we just found, 11 over 24 pi a squared h, is equal to 7/64 pi a squared h squared, and the a squares will cancel and we'll be left with the centroid in terms of h, which we get to be 21 over 88 times the height of the semiellipsoid for the answer for the component 1. Now we can use the same method to find component 2. Now the differential volume is going to be the same because we're still integrating a disk through this semiellipsoid. But the integral for the volume for component 2 is going to go, instead this time, from halfway through, h over 2, to all the way through the height. And we can plug in the same dV. Solving the integral, we get this. Simplifying further, we get that the volume for component 2 is equal to 5 over 24 pi a squared times h. Now we just need to find the right side of this equation, we have the differential element, dv, the integral of that, integrating from h over 2 to h, plug in x for the differential element as it varies throughout the x-axis. And we know dv. Solving the integral, we get pi a squared over h squared times h squared x squared over 2 minus x to the 4th over 4, all from h over 2 to h. We get the right side of the equation is going to be 9 over 64 pi a squared h squared. Now we can plug everything in and find the centroid of this second component. We have the volume 5/24 pi a squared h is equal to 9 over 64 pi a squared h squared. We get the centroid of the second component is equal to 27/40